Hello, James Flaten here. Third video of 3, talking about calculating stability, static margin in particular, for a very simple rocket. I just did a calculation by hand. Let me remind you what that rocket looked like. So basically it had a nose cone, it had a body, it had 4 fins, and then here are the values. 4 inches tall for the nose cone, 2 inches diameter for the body and the nose cone, 10 inches tall for the body. And then here's some characteristics about the fins. There are 4 of them. The root length A is 3. The tip length B is 2. They stick out 2 inches, that's S. They're swept 1 inch, that's M. L is the distance from the middle of the root to the middle of the tip, that's 2.06. And then the body itself has a diameter of 2 inches and hence a radius of 1. And then the nose cone will weigh 3 ounces. The body will weigh 4 ounces. The fins will weigh half an ounce each. Let's see if we can capture all that information in an Excel spreadsheet and then do the calculations. And then if you had a new body or new fins or something, you could just enter fins, 3 of them instead of 4 of them, and the calculations would proceed as planned. So let me switch over to an Excel spreadsheet I have planned for this purpose. And let's take a look at how this works. So right now I have in this Excel spreadsheet the values from this simple calculation with the expectation that you might use the same spreadsheet to calculate more complicated things. Let's look around. First of all, here are the names of the parts. So a conical nose, a body tube. You might later have a motor mount tube, some centering rings. For my calculation, I will have fins, but I won't have any motor casing, etc. So this here is how many pieces I have, 1 of each except for 4 fins. And this is whether or not the pieces are even present. So for my calculation right now, I'll have 1 nose cone, 1 body tube. I won't have any interior pieces. I will have 1 set of fins. There are 4 of them. Okay, so this is absent present. Present means it's there. Present means 1. And then there won't be a motor casing. Here are the lengths. So remember the nose cone is 4 inches long and 2 inches in diameter. The body tube is 10 inches long and 2 inches in diameter. And the fins are 3 inches long. We'll have to put in some more fin details later on. In fact, let's just look at those right now. Here are the values for the fins. So there's the root length, there's the tip length, there's the sweep length, there's how much they stick out from the body. And then notice this one here, 2.06, is a different color. This cell is a different color because it's pre-calculated for you. In fact, up here at the top, if you can see my cursor, and if you can't, it's in the formula bar at the top, is the number 3. I've entered the number 3 in the cell that's supposed to capture the value for A, the variable A. And then below that, I've entered the number 2, I've entered the number 1 for M, the number 2 for S. But the number for L is not entered. The number L is calculated. It says, parentheses, C16 divided by 2 minus C17 divided by 2, on parentheses, caret 2, that means squared to the 2nd power, plus C19 to the 2nd power, the entire thing in parentheses to the half power, which is taking the square root of it. If I click here, what it will do is it will encircle the various values, all of which are nearby, which were used to do this calculation. So C16, that refers to A. So notice that A divided by 2, and C17, that refers to B. B divided by 2, take the square that, okay? And then add C19, that's S squared, and then take the square root of it. Geometrically, this calculates the value for L, okay? So you have to, in this particular spreadsheet, distinguish between things that you enter, like these, and things that are calculated for you. So the body radius is F6 divided by 2. If I click here, F6 is the radius, or the diameter of the nose cone and the body tube. And so if I want the radius, I just divide that by 2, okay? And down here, the value for the body diameter for fin calculations is just the value in F6. So you can enter and change numbers in the white boxes but don't make any changes to the numbers in the grayed out boxes. Those are calculated for you automatically. And for the homework that I'm presenting for my students, you need to enter some of those equations. Some of those calculations might not be provided. Let's continue to look this over. Over here is the weight. So this is the fin weight in ounces, okay, which is 3 ounces. The body tube is 4 ounces, and each of the fins is ½ an ounce. Now we come over to more calculated columns. So for instance, let's take a look at H7. H7 is how far is it from how far is the CG from the top of the part to the CG of that part? Okay, so for the body tube, the answer is half the length of the tube. And so it says I can calculate this value by looking up E7 and dividing it by 2. Let's just go and look at E7 divided by 2. E7 is back here. It's the length of the part. So the idea is CG is half the length of the part down from the top. So that was an easy equation. And CP is also half the length of the part down from the top. And now here the question is, how far is it? What is the station? I'm sorry, not the station, but what is the distance from the top of the part to the 0 line? And in the case of the body tube, that number should be an E6. So let's go and look at what E6 is. That makes sense. Also, E6 is the length of the nose cone. So again, if you have a drawing, you'll see that the top of the body tube starts at the bottom of the nose cone. So the distance from the body tube top to the 0 line is the length of the nose cone, and this will be calculated for you automatically. So for instance, if I made a change, let's say I went over here and changed the nose cone length to be 2 inches, 2.5 inches, 2.55 inches, just to make sure it's some kind of funky number. So the nose cone length is 2.55 inches, and if I hit enter, it will automatically calculate new values over here. So it says now the body tube is 2.55 inches from the 0 line. Let me undo that change. Control Z, bring that back to 4. And then here's the CP station. So the CP station for the body tube is add J7 to H7. So let's think about what that means. J7 is how far it is to get to the part. And then H7 is how far into the part you need to go. And so you need to add those together to get the station for CG. Similarly for CP, in this case, what you need to do is you need to add together how far it is to the part and the distance to the CP of the part, but that's in I, column I. Sometimes the distance into the part for CG and into the part for CP will be different. Okay, so again, leave these equations alone. But when you are given the homework, you may need to find the equations that are missing and add them in. So for instance, in this case, if what I wanted to do, let me just show you how I would put this value in. I already know the value, it's J7 plus H7, okay? Let me just erase that. Now, so I want to have an equation that is how far it is, what is the CG station? Okay, and so I would say, I would click on that cell, and then I would go up to the entry box, and instead of typing in a number, I would type in an equation. So I would say equals, and it says, okay, how am I going to calculate that? And I would say equals, and I would click on this value. So in other words, it automatically puts J7 into the entry bar up there. It equals the distance from the tip of the nose to the top of the part. And then I would say plus, and then I would click on how far into the part. J7 plus H7. So I'm not even typing J and H. I'm just clicking on the appropriate cells, and it will automatically type them in for me. And then when I hit return, it will start to do the calculation. Okay, let's take a quick look at the fins. So there are 4 fins, total length 3. And in the case of the fins, here's a fairly complicated equation. How far is the center of gravity for the fins from the top of the fins? And that's going to be one of the equations in the slides. And here it is, C17 squared and 2/3 of C18 squared, and you have to add C18 times C17, multiply by 2, and divide by something, something. Okay, this is the kind of equation that you'll need to enter into your spreadsheet. It happens to be in mine already. And then here's another equation. How far down do you have to go to get to the fins? And in my case, my claim is add the nose cone length to the body tube length, and then subtract off the root length of the fin. That will get you to the top. On the other hand, calculating the CG station and CP station are very similar. This one was J7 plus H7. This one is just J11 plus H11. Okay. Down here, I have a place, and the equation is already there for how to calculate the normal coefficient associated with fins. That's a pretty complicated equation. And then down here is the fin body interference factor, and that's a not too complicated equation. But the fact that it's yellow suggests that it's probably not in your document. You'll have to add that in. And then down here, here is where I'm going to add together all of the values. So for instance, this says, what is the total weight of this part? Now you might think the total weight of this part should be pretty straightforward, but what I'm going to do is I'm going to see how it was calculated. G6 times C6 times D6. What are those things? Well, first of all, G6 is the actual weight, but C6 is how many of them you have. That's one. And then D6 is, do you even have this part? Okay, and the reason is if you don't have the part, I want to multiply this by 0 to make sure that whatever weight is there doesn't impact me. So you might say this is a little obtuse, but it helps me manage to have more than one part. It also helps me to take the part in or out and see the effect of that pretty quickly. Okay, so the body tube is the present, but there's only one of them. And the fins down here, notice that the fins are present, but I have to multiply the fact that there are 4 fins. So I'll end up with 4 times 1/2 gives me 2 ounces here. And then over here, now I'm going to calculate CG station times the weight. So the weight is right next to me, B27. Okay, that's the 3. But the CG station value is up in K6. Let me just go look for that. So I'm going to multiply the weight here, but I'm going to multiply that by the station, which was calculated way up here, right there. Okay. So again, keep your wits about you. This table will allow you to quickly calculate the total weights and the CG station times the weights. And then once you're done, if you want to get the CG overall, all you have to do is, let's see, I forgot one thing. Down at the bottom here is the sum. So this one says sum B27 through B33. In other words, add together all the numbers in the table above. That would be the total weight, 9 ounces. That should look familiar. And here is the total of the CG times weight. So that happens to be 70.47. Hopefully that's also familiar from my hand calculation. And then if I just divide one by the other right here, I'll get C35, that's the total CG times weight, divided by the total weight, gives me 7.83. I might have made a typo in my other document that said 7.88. Anyway, 7.83 is the overall CG. That's how far in from is the center of gravity for this object. This table is similar, except it will be for the center of pressure numbers. So you have to add up the center of pressure normal coefficients. The answers here should be familiar. And then eventually you'll get the center of pressure location. And now the question is this stable or not? Well, I have to calculate the static margin. So the static margin will be just take the difference between the center of pressure location and the center of gravity location, divide by the diameter, look that up somewhere else in the table, and then you can type in the word stable or unstable or marginal or something like that right here. Okay, so the nice thing is, once I've organized it and I've given you 95% of this, and you just have to fill in a few calculations, I would suggest you fill in the calculations as you believe they should be, and then put in these numbers and see if you get the right answer. I've even given you a screenshot of this particular document without all the equations showing. And once you have the right answer, and of course talk to other people too, then go ahead and put in the actual values expected of you for the homework, if you're watching this and are in my class and have some homework too.